Hi guys, today we are going to see how to generate combinations. Okay, so what are combination, and we will talk about permutation also, because permutation is not included in this question. Okay, but we are going to talk about permutations and then combinations. Okay, so let me tell the question statement. What question is asking us to do? So basically we are having some boxes. Let's say we are having 4 boxes, and yeah, we are having 2 items. Okay, so these are provided in the question, 4 boxes and 2 items. What we have to do, we have to print all the combinations which can be generated after putting 2 items in 4 boxes. So what I said that we have to put these 2 items into 4 boxes. We have to put these 2 items into 4 boxes, and we have to print all the ways in which we can print this. So let's start our discussion. Basically, we are having 4 boxes, and for the initial purpose, let's take we are having one item. We are having one item. So what are the possible ways? These are boxes. These are boxes, and we have to place one item. So items are identical. Items are identical, and in any box, if you are placing the item, you have to write there I, and if any box is remained empty, then in that case you have to print dash. Understood? So you will clear your doubt. Basically we are having first box as empty. Initially all the boxes are empty. We are having one item. So what I did, I placed our item in this box. So I placed my item. Now I have 0 item left. So these boxes will remain empty. So one of my combination is I dash dash dash. Okay, that's good. Now let's move to second combination, which is I said that I will not place in this box. I will not place in this box. I will place in the next box. Next box. So this remained empty, and I is placed here, and these boxes will remain empty as we are having 0 number of items. So what will happen? Dash I dash and dash. Okay. So let's generate third combination, in which I said that I will not sit in second box also. So this will remain empty. This will remain empty. I will sit here, and this will remain empty. So dash dash I dash. Last combination, which is dash 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 I. What does this mean? In this, I said that I will not sit in first, second, third. I will sit in fourth block. So these are the 4 combinations. These are the 4 combinations which we have generated. Okay. So what is the working? How we are going to generate a bigger number? Let's say, because this is one now. So for 10 boxes, and 5 items, there are so many boxes and so many items. So many combinations are going to be placed. So how you will determine that how many combinations are going to be generated? So we have studied in the childhood that to select k items, or to select r items from n items. To select r items from n items. What's the formula? NCR. What this formula is suggesting? This formula is saying that we are having n items. We have to select r items, and we have to select represented by C. So r items are going to be selected from n items. This is represented as r items is going to be selected from n items. Okay. So what is the formula? N factorial, r factorial, n minus r factorial. Very easy. So let's check about this problem. We are having 4 boxes. So 4 factorial. We have to select one box. So 1 factorial into 4 minus 1 factorial. So what will be our answer? 4 factorial upon 3 factorial, which is equals to 4. So there are 4 number of ways in which we can select a single box from 4 boxes. What are the ways? Either I can select this box, either I can select this box, either I can select this box, either I can select this box. Understood? So what this number is representing, that I can select 4 boxes. Oh no. There are 4 number of ways in which I can select one item from four items. Okay, this 4 is representing us that we can select one item from four items in four number of ways. So you can analyze now that if there are four ways in which one item can be selected from four items, so this 4 is represented as four four ways to put one item in four boxes. This 4 can also be stated as there are four number of ways in which I can place a item in four boxes, because if an item is placed in four ways in four boxes, so there are four number of ways in which I can pick them. Basically, if I will put that item in that way also, I can pick that also. Understood? So let's move to some difficult example so that you can clearly understand what I mean to say. Let's say there are four boxes and two items. Very easy. Okay, so we will talk about permutation also. Okay, we will take permutation simultaneously so that you can understand the difference between permutations and combination. So initially, let me tell you that after all this discussion, I will state you two lines. I will write two lines on this board, and those two lines are very much useful in every programming question related to permutation and combination. Okay, those two lines will be very useful for you. So I will write here combination. Basically, I am going to generate combinations here and permutation here. Very easy. Now for four boxes and two items. For four boxes and two items. Basically, I have to place two items in four boxes. So here I am going to write combination. Here I am going to write permutation. So before creating all our permutation and combination, let's analyze what should be our answer. What should be our answer? For combination, 4C2 should be our answer. And for permutation, 4P2 should be our answer. So I will expect you that you should know the formula for 4C2 and 4P2. Basically, 4P2 represents 4 factorial upon 4 minus 2 factorial. And this 4C2 represents 4 factorial upon 2 factorial into 4 minus 2 factorial. Okay, these are the formulas. Okay, so we will come to that point. But firstly, let's start creating our combinations and permutations. Okay, very easy. So in question we are given that we are having identical items. But for the explanation purpose, I am taking first item as 1, second item as 2. So that you can clearly understand the difference between combination and permutation. Okay, for that purpose only, I am taking 1 and 2. The logic is same, exactly same. There will be no effect on our answer. Okay. So first item is represented by 1, second is 2. So basically we are having 4 boxes. So 4 empty boxes. What one said that I will place here. I will be placed here. 2 said I will be placed here. Easy. So I have placed all my items. Now this is one of my combination. Okay. Now again, 1 is placed here. 2 said that I will not sit here. I will not sit here. I will sit on the next bench, next box. Okay. So this position is remained empty and 2 sit here. Very good. After that again 1 is placed here. 2 said I will not sit here also. So 2 said I will sit here. Okay. Now can 2 say that I will not sit here? I am asking you whether 2 can say that I will not sit here. I will sit in further benches. No, because there are no further boxes. So 2 should be placed on this index. Should be. Okay. After that, this is the main case which I wanted to explain you. This is the main case. Okay, just focus on this case. Now 1 said I have generated all the combination for 2. I have generated all the combinations for 2. Okay. Now 1 said that I will not sit here. 1 said I will not sit here. So 1 can be placed here also. So 1 said I will sit here. Now just tell me what are the ways in which I can put 2 in these boxes. So there is a way that 2 can be placed here. There is a way that 2 can be placed here. There is a way also that 2 can be placed here. There are 2 choices for 2. Either 2 can be placed before 1 and second choice is that 2 can be placed after 1. So if we take the red one, if we take this choice, then it will generate permutations. It will generate permutation. Why? Because this is called as arranging. This is called as arrangement. Basically, permutation can also be called as arrangement. Okay. And combinations is called as selection. As I mentioned before, in which we have to select one item from 4 items. So this is called as selection, and this is called as arrangement. Arrangement means, just take an example. I'm going to tell you a practical example. Basically, 4 boxes are placed in front of you. 4 boxes are placed in front of you, and in first 2 boxes, red and green ball is present. In first 2 boxes, red and green ball is present. Your eyes are closed. Your eyes are closed. You put it both of your hands in first and second box, and you picked both the balls. You picked both the balls. So this is called as selection. Why? This doesn't matter for you that whether in my left hand red ball is present or green ball is present. This doesn't matter for you. You have to select the balls now. So you close your eyes. So there are 4 boxes. You placed your hand and you found 2 balls in the first 2 boxes. This is called as selection. But in arrangement, your eyes are open. In arrangement, your eyes are open. Now you have to select. Now let's say you have to select red, then green ball. You have to select red and then green ball. So what you will do? Basically, your eyes are open now. So in first box, let's say red and second box is green. This is present. So you can pick both the balls. In this case, you can pick both the balls. But let's say in first box green is present, second box red is present. So green and red, this is not suitable for you. So you will not pick that. So in this case, what we have done? We have done arrangements. In previous case, what we are doing? We are just selecting. We are just selecting whether it is green, red or red, green. This doesn't matter. We are only selecting. So this is the difference between selection and arrangement, combination and permutation. Understood? So we have seen 1, 2 here. So this doesn't matter whether 2, 1 is present or not. We will not check for that. So this case is invalid. Because this doesn't matter for us. Because we have put it both of our hands and our eyes are closed. So we found that 2 balls are present. I don't know whether it is 1, 2 or 2, 1. I don't know. So I found 1, 2. So I will not place again my hand in these 2 boxes. So what I will do? I will place 2 here. Because I will check for further boxes. Now I will check for further boxes. Understood? So I hope you guys understood why we cannot place 2 here. Because if I will place 2 here, then it will create permutations. I will explain you. This case is going to be put here in permutation. Okay. So 2 side I will place here. 2 side. Okay. Now 1 is placed here. 2 side I will not place here. So 2 is placed here. Very good. After that, 1 side that I will not place here. I will place in the second just after box. So this side 1 is placed here. Now I am asking you, can 2 be placed here? Is this correct? No. Is this correct? This is also wrong. Is this correct? Yes, this is correct. Okay. So 1, 2. And now 2 is not having further choices. 1 is not having further choices. So we stopped and we found our answer. That these are the total number of ways in which 2 items can be placed in 4 boxes. And you can check. Also 4 factorial upon 2 factorial into 2 factorial. 4 factorial, 2 factorial into 2 factorial. This is equals to 4 upon 4 into 3 by 2. This is equals to 6. Understood? So 6. Yeah, these are having 6 number of ways. We are correct. Now let's generate permutation also. Let's create permutation also. 1, 2, 3, 4. 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Understood? So these are the permutations that I am going to create. Basically, these are exactly same. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1 and 2. These are going to be same. But this is permutation. So green and red matters. Their arrangement matters for us. So 1, 2 is placed here. So 2, 1 can also be placed here. 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. These are permutation. Okay. So arrangement matters for us. If arrangement matters, then we are going to find a permutation And if combination is matter, this doesn't matter. Just whenever you are facing some question, examine whether their arrangement matters or not. If it matters, then permutation will be used, and otherwise combination will be used. Okay, so I have explained enough, and let's move to the two lines which I said that I am going to explain you or write it. So two lines. What are the lines? If you are finding combination, then this is a trick, or you can simply say that this is the way in which you should find combination. You are having two choices, whether I will put or I will not put. Okay, you are having two choices, whether I will put or whether I will not put. But in any of the choices, whether you are putting that item or not putting that item, after that you will check for further indexes. You will not check for indexes just before that. Basically, these are the two, these are boxes. If you placed I here, there are two choices, whether I can be placed here or I cannot be placed there. Two ways. Okay, but after this, after placement or non-placement, what you have to do, you have to search for, you have to determine whether you are going to put I here or not. Okay, so you will not check for these cases, you will not check for these indexes. Whatever index you left behind are left behind, you are not going to check for them. But in permutation, again and again you are going to start from 0th index. Again and again you are going to start from 0th index, whether you have put the item in this box or not. This doesn't matter. You have to start from 0th index. Understood? So these are the cases. In technical terms, let's say your index value is 4. Now in combination, you will pass index plus 1 to our recursion function. Okay. And if in permutation, index value is 4. So while calling the recursion, you will pass index value as 0, so that it can start from again also. Understood? So these are the basic difference. Now let's move to our code. Basically, this is very easy. Okay, there are 2 to 4 lines of code, but our main focus is on logic, to build our logic. Okay, to not get confused in between permutation and combination. Okay, so let me explain what are the parameters. This is called as current block. This is total block. This is this is called as item so far, or you can simply write here current item. Okay, how many items I have put it till now, and now total items. Okay, and answer so far. So these are some parameters which we are required. Now what we will do, basically we will check. So I am writing the base condition. If current block is greater than total block, that means I have covered all of my boxes. Let's say these are my 4 boxes. This is CB1, CB2, CB3, CB4, and I am standing at CB5. That means I have covered all the boxes. So in that case, I will hit my base condition. And when I will hit my base condition, what I will check? I will check whether I have placed all the items or not. I will check now. So if current item equals to total item, that means I have placed all the items. In this case, I have to simply print my answer so far and then simply return. Easy. And what are the two possible ways? Two possible ways are whether I will put or I will not put. In both of the cases, I will move to my further boxes. So just exactly combinations. Current block plus 1. That means I will move to my further boxes. Whatever choice I will make. Total blocks will remain same. Current item plus 1. That means I am placing. Currently in this case, I am placing my item. Total item will remain same. And if I am placing, I have to add I to my answer so far. And exactly same. CB plus 1. I will move to further boxes. Current index will not change because I am not placing my item in this box. Total item and answer so far plus dash. Finished. Okay, this is the whole code. This is the whole code to generate all the combinations. Okay, that's submitted. So I hope you guys understood what we are doing, how we are determining whether to put or not. What will happen if we put the item previously. Basically, as I said, that if we are having 4 boxes, if I is placed here, I1 is placed here, you cannot put I2 here. I have explained why we cannot put I2 here, because it will generate permutation. So this is all about this question. I hope you guys understood. We will meet in the next video. Until then, bye.